Hey guys, Mr. Milton here. Today we're looking at, oops, I don't have the title in here. Area and volume ratios notes. At the end of this video, you should be able to use the area and volume ratios of similar solids to find missing areas and volumes. All right. Remember that we talked about similar figures last semester. Similar solids have the same shape and all sides are proportional. So very similar to, we talk about similarity, we're talking about proportionality. Okay. The ratio of corresponding linear dimensions is called the similarity ratio, right? The ratio of the squared dimensions is called the area ratio. And the ratio of the cube dimensions is called the volume ratio. If the similarity ratio is A to B, then the area ratio will be A squared to B squared, and the volume ratio will be A cubed to B cubed. Okay, so let's look at this with some numbers. Okay, if we knew that the similarity ratio between two similar prisms was 3 to 5, their area ratio would be 3 squared, 9, over 5 squared, 25. The ratio of their volumes would be 3 cubed, 27, over 5 cubed, 125. So let's use that. It says, given that two cones are similar, what is the volume of the smaller cone? So they told us that these two are similar, so we don't have to worry about that. And then they gave us their radii. Okay, so since they're similar and we have a corresponding measurement, we have our similarity ratio of 2 to 5. Okay, we're going to use that, since they're asking about our volume, to find our ratio of volumes. So we're going to go from our similarity ratio of 2 over 5 to our volume ratio of 2 cubed over 5 cubed. So we could use that to come up with a number, but it's way easier to write 8 over 125. Okay. Now that we know that it should work with this ratio, we can set up our proportion of 8 over 125, since that's the ratio of their volumes, should equal x over 8,000. Okay. As we set this up, notice that 8 is the smaller number, goes with the small cone, and the unknown value or the unknown volume goes with the small cone. Okay, 125 is the large number, and the larger volume is 8,000. Okay, so I guess we did small over large. Okay, if that's helpful. Okay, so we cross multiply, solve, we get 64,000 equals 125x. 64,000 divided by 125, and that gives us 512. Okay, meters cubed. Next problem, it says the volume of two similar pyramids is 729 centimeters cubed and 1,331 centimeters cubed. If the lateral area of the smaller pyramid is 60 centimeters squared, find the lateral area of the largest pyramid. If necessary, give your answer to the nearest 10. So here's how we start. We start knowing the volumes of both of these figures. We're given the volume ratio. Okay, and that's 729 over 1,331. Okay, so our volume ratio, we're going to go from volume ratio to similarity ratio. Okay, I know that we really care about the lateral area, the area ratio, because that's going to help us out. But we're given the volume ratio and we need the area ratio. But we can't go straight from cube to square. We won't go straight from cube to square. What we're going to do is we're going to go from cubed, because this is like a cubed over b cubed. It'll be easier for us to go to a over b. So we're going to take the cubed root of 729. We're going to take the cubed root of 1,331, and we're going to get what our similarity ratio is. So the cube root of 729 gives us 9. And the cube root of 1,331 gives us 11. Okay, so we went from volume ratio to the similarity ratio, right, A over B. And then we're going to go to the ratio that we really care about, and that in this case is the area ratio. And that'll be A squared over B squared. And once we find out what A is, A squared is easy. 9 times 9, 81. B squared, 11 times 11, 121. So now we have the ratio that we want, the area ratio. Okay, didn't want that. Okay, and so we can set it up as 81 over 121. They gave us the area of the smaller pyramid of 60. So we'll put 60 where the smaller number is, and X where our large number is. So we'll cross multiply 81X equals 7,260. 7,260 divided by 81 should give us our answer, which is 89.62. Okay, and since it says to the nearest 10th, 89.6. Last problem here. It says a box of detergent shaped like a rectangular prism holds 3.25 pounds of detergent. How much detergent would a similar box hold with dimensions 3 times larger than the original box? So here's what we got. We got a box, small box. All right. X, I don't know what these numbers are. Okay, these dimensions. Okay, now they're saying, hey, what if we had a large box? You get the Costco brand detergent. Okay, and it's 3 times as large. Boom. So we got, this is 3X, this is 3Z, this is 3Y. Okay, how much more detergent will we need? Well, as we look at it, we can say, okay, well, they gave us the dimensions is 3 times larger. So really, they gave us the similarity ratio. They told us, hey, our similarity ratio is 1 to 3. How much more would it be able to hold? When we're talking about weight or holding weight, we're talking about a volume. Okay, so we're going to go from our similarity ratio to our volume ratio. So that'd be A cubed over B cubed. Okay, seeing that we got A and B. So our ratio of volumes would be 1 to 27. Okay, so we can set up our proportion and say, okay, 1 over 27 should equal 3.25 pounds, because that's how much the small box weighs now, or can hold now. And X would be how much the large box should hold with these dimensions. So we cross multiply 27 times 3.25 gives us 87.75. So this new box would be able to hold 87.75 pounds of detergent. Okay. All right, and that is our ratios between area, volume, I guess, and similarity ratios too. All right, see you.